start with the first of all create instances, and here we have already taken the library of GPTK45, and let's browse. And after going in browse, you will select the GPTK45 as this is our library, and in this you can search over here uh, NMOS. For selecting NMOS, this is NMOS 1 volt, and symbol is already given. So simply we have selected this. Okay, so hide, and we have got the NMOS over here. We'll place NMOS here, and for selecting deselecting this, press escape. Now let us select the PMOS, so we can write here as well, just write N placed by PMOS 1 volt and we will select our PMOS over here. Okay, so this is will be our PMOS. So we'll place our PMOS over here, and just alright. Okay, if we need to copy these instances, just click them, press C and click them, and it's not copying. Why it's not copying? So okay, it is selected. Place them here. Okay, to create the transmission gate logic, click on the CMOS, and where is our rotate? Right, set this. Okay, so let's move. We have already rotated this PMOS, and now let's flip it horizontal. Flip horizontal and select this PMOS. Yeah, it's flipped. Now it's time to rotate this NMOS. So click on this, rotate right, and rotate right this NMOS, and we have to flip it. So flip it vertical, and yeah, once a minute. First flip it horizontal. Okay, flip it horizontal, and now flip it vertical. And yeah, and we have done with that. We have to flip it again. Flip horizontal. What's happening? Flip horizontal. Yeah, it's nice. Yeah, so let us make connection. So for connection, click on here we can select a wire. The wire, just click on this, and we have chosen a wire. This is the way we can click on here. Okay, so let us move forward. Here we have already making a transmission gate for this PMOS and NMOS, and we have already copied this for another transmission gate. And we have built a connection between PMOS and NMOS here using wire. We can select from here, this is a wire, and to remove this, press escape. Okay, so we have connected both the sides of PMOS and NMOS. Here the drain of PMOS to the drain of NMOS, and the source of PMOS to the source of NMOS. And since we have copied this, so this is again another transmission gate. So let us select a wire and join these as well. We have joined these. Okay, and we are also supposed to connect the outputs of the transmission gate. Okay, so this is how, using a wire, we can connect the output of the transmission gate. And we have a so let me show you how to assign a pin for output. So let me delete this first one. Okay, so here, okay, I have deleted this. Okay, so again choose a wire and place a wire till here. You can select as long as you want, but I have just taken this much. Okay, so escape. So click on this pin here, create pin. You can assign I am taking Y as output, so give it a direction. Okay, give it a direction as output, height, and just place it here. And the output has been given. Okay, so now we have to connect these inputs of inverter. So again, click on a wire, connect these two inputs. Alright, and we have already joined these PMOS and NMOS with their bodies. We will click here and select a wire, and we'll join. This is must to join. Okay, and here VDD and ground has already been taken, same as. We'll go here, we'll write VDD and space ground, and we'll give them a direction or whatever you want. Just hide them and we will put them here. Okay, so for select line, let me again show you how to select line input. So let me delete it first. Select a wire, place this wire till here. Okay, so escape and create on this again as SEL for select line input. Select line will work as an input, so let me give it a direction of input. Input, and we have given this as input, and we have already assigned an input and output pins for these VDD and ground. Okay, so now let us build a connection between these transmission gates, and we'll connect them with the transmission line according to the circuit of multiplexer. Okay, so let us take a wire. Okay, so for the gate, from the gate of transmission gate 1, we'll connect them together like this. Okay, so we have connected this, and we already let me connect these two gates as well, from this PMOS, this NMOS to this PMOS. Alright, and now again we have to make a connection between these select lines with these connection of these transmission gate. So we'll click on here, and now we have made the connection between select line and transmission gate. One more connection that we have to make over here. This inverter will directly connected with the associated gate of these transmission gate. So we have a wire, and we'll click them like this, and we'll connect them this way. Okay, so now it is connected. So this way we have completed our circuit for schematic for transmission gate. Alright, I think everything is connected, so we are done here.
Can we start? Now let's save this design. After this we have to create from Thelview. And now okay, now we want three left pin, that is I1 and select, and we want right pin is Y, that is output, and we want top pin, that is VDD, which is the power supply, and the ground should be the bottom pin. So let's make it on bottom. And now okay, now open this, make it on the center. Now delete this extra part, uh, this one also, this one also, and choose the line from the top bar, make a straight line. Let's make it again. What happened? Now let's make this square box. No worries. Square box is. What's the problem happening? Now let's make the line. Now we have to move this line. We have to move this line to here. Now this ground pin also here, this ground here, this here, this I1 and here, and the VDD line as well in the top. Let's add VDD here. Now this pin add as well. You have to make it just for the simplicity of the design. Add it here. Now put this as well here and this Y here. Okay, now this should be the 2 cross mark 1 marks. Okay, now move this as well. From here and rotate it right. Just a minute. Rotate right. Done. One more. Okay, now check and save the design. Okay, the design is saved. Now delete this window. Now from here, uh, we have to file, new, mix, test, schematic. Okay, now from here you can open the intrinsic PMOS, browse to cross one marks. Now check this and close this and move this here. Okay, got it. Now make it on the center. Now we have to do the arrangement of vehicles and go to analog libraries first, search vehicles. It should be kept small vehicles, I think. Let's choose again, browse vehicles. Okay, close. Now from here we have to give some values, and the values are voltage 1 is 0, voltage 2 is 1 volt, and the rise time should be 100. Nano, 10 nano. Period, first let's make period 10 nano, then it should be rush time should be pulse width should be 5 nano, and rush time should be 0.1 nano, I think. Let's make it 0.1 nano, and the fall time should be 0.1 nano. Now make hide and choose the 3 similar waveform for the 3 different lines we have. Make it on the center like this, select and move this toward right. Similarly move this right. Okay, now go to analog libraries, find ground, and make hide and give the ground here, 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 here as well, and one ground should be here. So next click is center, escape. Now make the connection using W, which is wire. Connect the top pin to the okay, make the connection from pulse 2 to I1, make the third connection pulse V2 to selection line. Now make the ground connection. Now we have to take the VDC, which is the DC voltage, and DC voltage should be here. Let's make it first here. Now center. After that choose, and we have to move it from here to here, and this is as well from this should be connected to the ground. Now make it on. Now make the connection. Connect the VDD to this voltage. Now what should be the next? The next should be we have to assign the I0, I1 and selection pins. Like let's assign D0, D1 and S. Assign D0 here, D1 here and S here. We have to assign the different name as we have assigned the first, like we cannot assign I0, I1 and selection line from here. So now let's make the output pin, which is out. This should be output schematic. Okay, this should be here, and now make the connection of this as well. What left? I think everything is done. Now we have to make the different, like these both of the three balls are same, so we have to take all the three balls different. So let's click on here and press Q. Make it pulse with 10 and it should be 20. Okay, and now here Q, it should be 20, then period should be 40. Okay, now I think everything is look fine. Now may assign the voltage from press Q, and the DC voltage should be 1 volt. Okay, so I think everything is fine right now. Now let's check and save. Everything is done, I think so. Now make launch. After that after the launch press ADL. So it should be session. Now open this ADL, transient, and the stop time should be 10 nano. Choose moderate and OK. Now here we have to make edit from the design and choose D0, D1 selection line and the Y output. Now open this. Everything is look fine. Now open the ADL. Variable setup session. Model libraries. Let's see if the model library is selected or not. Yes, the model library 45 is selected. So now run and end this at least. So let's see if there is.
टीम हम लोग कर रहे थे पहले सेलेक्ट रहा होगा
Now we have to choose the variables. We have to choose the variables, and from the setup first we have to find out that the model library should be 45 only. The like our transistors are from 45 nanometer scale, so it should be 45. So okay, now run a netlist. Let's see, is there any error? So finally it's running. So make it like this. Output selection line denote D1. Like if the selection line is high, the output should be if the selection line is high, the output should be D1, and if the selection line is low, the output should be according to the denote. Like as you know that the output is according to the 2x1 multiplexer. So that's it. Now we have to stop the video.